Hey everyone, welcome back, and today let's solve Leetcode problem 2381, titled Shifting Letters 2. So we're given a string S of lowercase English letters and a 2D integer array shifts, where shifts at index I is equal to a starting index I, an ending at index I, and a direction at I. And for every I, we want to shift the characters in S from the index start sub I to the indexed end sub I inclusive, which really just means we're including the start and end endpoints as well in that range. And we're shifting all the characters in that range forward if direction at sub I is equal to 1, or if it's equal to 0 for that actual index I, well then we want to shift all the characters backwards for that case. So shifting a character forward means replacing it with the next letter in the alphabet, basically in lexicographic order, and it does kind of have that circular motion or factor where we're wrapping around so that the string Z wraps around and becomes a string A. And similarly, shifting a character backward means replacing it with the previous letter in the alphabet, and so that would mean wrapping it around so that the string A becomes a string Z. Right? Kind of maintaining that circular logic. And we need to simply return the final string after all the shifts that we see in the shifts input array to the string input S are actually applied, right? That resulting string. So in example 1, we have our input string S to be ABC and our shifts to be the following. We have 3 different shifts to make. These are our 2 starting and ending indices, and these are the directions to tell us whether we're shifting the characters in those ranges forwards or backwards, like they kind of described in the problem statement above. So in this case, our output is going to be the string of ACE, and the reason why is because, first of all, we first want to shift the characters from index 0 to index 1. But which direction do we want to shift them? Well, if you look at the first query that we're first shifting first, we shift the characters from index 0 to index 1 from start to end, and inclusive, and we want to shift when direction is 0. And direction is equal to 0 when we want to shift backwards. And so in this case, or rather right here, right? And so in this case, we're going to shift all the characters in that range backwards. And so the resulting string would become ZAC. Okay? Right? And keep in mind this A would wrap around to become a Z, maintaining that circular wrapping around logic. And then we want to shift the characters from index 1 to index 2 in the second query forward, because in this case the direction is 1. And so then we would get a resulting string of ZBD. And finally, after we shift the characters from index 0 to 2 when direction is 1, so forward, we get a final resulting string from ZBD to ACE. And believe it or not, that's all the operations we need, because the length of the shifts array, or the number of shifts we have to do, are going to be 3. And so once we're done with all those 3 shifts or operations, we simply return the resulting string, which would really just be the string ACE. And of course, that's exactly why our output is the string ACE. In example 2, we have our input string S to be DZTC, and in this case, we only have 2 shifts. We have 0, 0, 0, and 1, 1, 1. And in this case, we have an output of CATZ. And the first operation that we're going to do is simply just shift the characters from index 0 to index 0, so just literally index 0 in the input string S backwards, because in this case the direction is equal to 0. And so then we get CZTZ, okay? And then finally, we simply want to shift the characters from index 1 to index 1, so just index 1 forward, because the direction is equal to 1. And our final string would then be CATZ, or CATZ. So for the constraints here, we see that the length of our input string S and the shifts input array are not going to exceed 10 to the 4th power times 5, which, keep in mind, is a pretty large number, especially when dealing with time and space complexities. And for the length of every single query or shift in the shifts array, we know that there are always going to be 3. We have a starting index, ending index, and a direction. And we see that the starting sub I is always going to be less than or equal to end sub I, which is always going to be less than the length of our input string S, because we don't want to make a valid split, or rather a valid change, right? And we see that the direction for any subindex I is never going to be something besides 0 or 1. So it is always going to be valid, and S is always going to consist of lowercase English letters, which is pretty good because it guarantees that we're always going to have valid, simple inputs to work with. So before we actually dive into the kind of high-level rundown of the solution and the code here, let me just zoom in real quick, and I'll give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so I just realized I was talking a little bit faster. I'm going to try to slow myself down for the explanation and the coding part as well. So, how can we kind of solve this problem efficiently using some kind of helpful data structures that we know? Well, believe it or not, to actually most efficiently solve this problem, we're actually going to be using a technique known as the difference array. Okay, and what exactly is the difference array, you might ask? Basically, it's very useful for handling range update queries like we see in this problem, where basically shifts is our input queries, and we're basically handling the range to update those queries. And what this approach really does is it actually allows us to apply multiple shift operations in kind of a cumulative manner to our input string s, and then process the string in a single pass in a linear time for loop. Right, so for some quick, very important observations that we can really make to this problem to help us lead to our solution, first of all, we have circular shifting, right? Again, shifting a character beyond the string z would wrap back around to the string a, and also vice versa. Right? And we can actually basically manage this circular behavior using some modular arithmetic operations. I'll get more into that as we actually start coding the solution. And for the actual difference array approach itself, basically by actually maintaining a separate difference array, we can actually mark the start and the end plus 1 positions of every single shift operations in our input shift queries. Right? And that actually allows us to compute the net effect of all of the shifts very efficient. Right? So for the kind of variables that we're going to be using, we're going to have n to be the length of our input string s. We're going to have, I don't know, the shift difference, right? Or the shift diff is what I'll call it when I'm actually coding it. It's going to be an array of zeros it's going to have dimensions or length n plus 1. And it's basically going to record the net shifts at each position, right? Or index I, right? And then the current shift is basically going to be a variable to keep track of the cumulative shift value as we actually iterate over our input s string. So with that kind of high level rundown out of the way, let's go ahead and dive straight into the code here. So like I was talking about before, I'm actually just going to call n to be an integer equal to the length of our input string s, right? This is just for easy access to actually store the length of our input string s in n, and then kind of use it later for efficient iterating over our array instead of having to type length of s. You don't have to do this. It's not the most important. I just usually do this for when I solve problems, right? Now, let's actually initialize our difference array, the main array that we're actually talking about to help us solve this problem here. So I'm literally going to call it shift diff, like I talked about before. Oops. And it's going to stand for shift difference array, right? And it's going to be initialized to all zeros, and it's going to have a length of n plus 1. Keep in mind, n is again the length of our input string s, and we're adding 1 to that. Right? And what we're actually doing with after creating this shift diff list of zeros, basically we're just gonna use it to actually help us record the net effect of all the shift operations, and you'll see how that actually pans out later on as we start iterating over our shifts array. Right? So now let's actually iterate over our input array shifts. So I'm gonna use something called packing and unpacking in Python here. You may or may not have seen it before. Basically, it's using multiple different iterators to actually efficiently loop over a string. So, for every start and end and direction, right, because we know that every single list in our input array shifts, as we saw in the constraints, is going to have a length of 3, the starting index, the ending parameter, and then the direction for that query. Right, so we're just basically unpacking for every single list in our input array shifts and looping over, of course, the shifts array. So in the shifts array, basically just unpacking using the start, end, and dictionary values and looping through every single shift operation in that input array shifts, right? So the first thing that we have to check is what direction value do we actually have for this current iteration or for this current query? Well, we know if the current direction that we're looking at, if it's equal to 1, like the problem told us, we want to shift all the elements in this range from start to end forward. And so if that's the case, we want to set shift diff at the starting value. Keep in mind that's one of the iterators for this current tuple or list of length 3 here, and we want to increment it by 1. And then we also want to increment shift diff at the ending plus 1 to be decremented by 1, so minus equals 1. However, if the direction is not equal to 1, so in the else conditional here, we know that if the direction is going to be equal to 0, that means we want to shift it backwards. So the way we handle that is saying shift diff at the starting index would simply be decremented by 1, basically the inverse of the forward operation, and then shift diff at end plus 1 would hence be incremented by 1. So to better explain why we're really kind of incrementing and decrementing the shift diff at these indices by 1 or by -1, basically, again, depending on the direction, if it's equal to 1 or 0, we have to update our shift diff array at these indices, right? So for a right shift where direction is equal to 1, we have to increment the shift diff at that index start, and then decrement shift diff at n plus 1 by 1. Right? And then for a left shift, when direction is actually equal to 0, we have to then inversely decrement the shift diff at index start, and then increment shift diff at n plus 1, each by 1. Right? And that basically marks the beginning and the end of that actual shift effect for this current query, or length 3, in this iteration of the for loop here. Right? So once we actually updated our shift diff array at these indices, now let's actually initialize our current shift that we're going to be using incrementally, basically. That's going to be cumulative as we actually iterate over our input string s. And then we're going to also have a result, which is eventually what we're going to be returning. It's going to be the resulting string once we're actually done applying the operations on s and storing that result in that string, or rather in that result. So basically, current shift is again going to be accumulating the net shifts as we actually process the string, and this empty list result is going to build the final shifted string, and it's going to be eventually what we return. So now let's actually iterate over our string input s. So for I in the range of the length of our input string s, or basically in this case just n, because that's exactly what we stored it as, right? Basically just looping over every single character index I in the string s. We first want to actually kind of accumulate that shift. And so for every single iteration in this, we want to set current shift in this iteration so far, and basically increment it by the shift diff array. So shift diff at this current index I, right? And basically, again, we're accumulating the shift here at the iteration. We're updating the current shift by adding the value at shift diff at index I, which is going to give us the net shift that we have to actually apply at this position or index I. Okay? So once we've actually updated that, now we actually have to get the new character. Basically compute the new character after applying the net shift. And so I'm going to be using some ordinate operations here. I'll explain it as we go. The new character, or the new char is what I'll call it to make it a little bit more simpler here. It's going to be the chr, I'll explain this as we go, of the ordinate or ord of s at index I, right? Just making sure I have my things right. S at index I minus the ord of the string a. Minus the ord of the string a, right? And once we have that, we're actually going to add onto it, so plus the current shift. And then, once we actually get this result, we want to then mod it, so mod it by 26, and then add on the ord of the string a, right? Sorry, there should be a parenthesis. And just verifying that I do actually have the right parenthesis kind of layout here. Okay, so, looks like I made a quick error here. So basically this should not be there. I don't know why I have an extra thing here. Should be gone, and this should be perfect. Okay, so basically to kind of reiterate what we're really doing here, we're actually computing the new character, right? This is going to be the new character after applying the net shift, right? And the way we actually do this is, first of all, what ord at s at index I minus ord at the string a really does, it basically converts the character to a 0-based index. So basically a would go to 0, b would go to 1, c would go to 2, and so on and so forth. And then we're actually adding on to it the current shift, right, that we increment at each iteration, right? And the current shift is basically going to actually apply the cumulative shift at this current index or iteration, and then the modulus of 26 is simply going to ensure that the result wraps around within those 26 letters of the alphabet. That's why we take the mod of it by 26. And the reason why we actually add the ord of the string a is basically to actually convert the 0-based index back into a character to kind of invert the previous operation. And chr, I like to call it cur, what it really does is it basically just converts the ASCII value back into a character, right? Like A, B, C, D, and etc. Right? So once we've actually computed this new character, we want to then add it to our result. So result.append the new character after applying this cumulative shift in this iteration here. So add to the current character, and then simply return the string.join of the result, right? Because the result is actually going to store all the resulting string after we apply all the shifts is going to be the final shifted result string, right? And the reason why we're just not returning the list but actually the string is because we want to return or join the list of characters into a single string. That's exactly what the output was supposed to be. Not a list, but rather a string of the resulting characters after applying all the shifts in that wrapping around or circular effect. Right? And basically, what we're really doing here on line 17 is actually building our result and appending the new character after computing it after the shifts to the result list. So unless I'm adding the syntax errors here, this should be accepted and this should be a valid solution. Okay, yeah. Looks like you guys can forward this part here. This is just me debugging my goofy little code here. You have the GHR of the ORD of S at index I. Okay, yeah. So there should be a parenthesis here. Now let's go ahead and check if this works. Okay, let's see what it, okay, so there should be actually 2 parentheses here. Now this should work. Sorry about that, guys. I just forgot some parentheses as I was actually coding this up. Let's see if this works. Oh, oops. This should be times n plus 1. Okay. Right. So, just to verify that I didn't make any other errors here. Sorry about that, guys. Okay, so there should be new character, not just character, because of course we defined it as new character when we actually computed it after these shifts. But now, as you can see, this is actually the most efficient solution. Sorry about my couple errors there. It was just me not realizing that I forgot some parentheses and misspelled new character. But now, as you can see, this is actually the most efficient solution. It beats about 100% of users and only takes 50 milliseconds for a runtime here. So for a quick kind of like high-level rundown of how we're actually kind of using this code here to solve this problem, basically we're just efficiently processing the multiple shift operations on our input string S by effectively just leveraging a difference array to record the net effect of all the shifts, and then we're simply computing the final shifted string into a single pass, ensuring that it is the most optimal performance that we can get. As you can see, we only have really one for loop here. Obviously, they're not nested here, and it really is just about as efficient as you can get. So for the time complexity, this is actually going to have a fully simplified time complexity of big O of n plus m, right? And the reason why is because this algorithm actually processes the shifts array, and it also processes the string S in separate linear passes, and so the overall time complexity is going to be big O of n plus m, where n is the length of our input string S and m is the number of shifts operations. And for the space complexity, this is just going to be a linear time memory complexity of big O of n, because we really just only use one auxiliary memory here, or one extra data structure. It's going to be this shift diff array of length n plus 1, or rather n is going to be the length of our input string S, right? That's going to scale with the length of our input string S, right? So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.